We are now going to switch back to verifying identities. And let's pick a side to start with. I'm going to pick this side because I see two terms that I can use some of our new identities on. Okay? And my hope is if I apply these new identities, then maybe I'll end up with this. Okay. So we have cosine of alpha plus beta plus cosine of alpha minus beta is equal to, and we're going to use those cosine formulas for cosine of a sum of two angles. And so this looks like cosine of alpha cosine of beta minus sine of alpha sine of beta. And remember these cosine ones, the sign in the middle is opposite of what's in the trig function. Okay. So now that we've applied this identity to the first one, let's apply the other identity to the second one. So we have plus cosine of alpha cosine of beta, the opposite sign in the middle, so plus, and then we have sine of alpha sine of beta. And let's see if anything cancels here. I see a minus sign of alpha sine beta and a positive sine of alpha sine beta. And I see actually two terms that are the same, so we can rewrite this as 2 times cosine of alpha cosine of beta. Okay. Now that we've completed part A, go ahead and pause the video and try out part B. Alright, in order to do part B, I'm going to start off again with a certain strategy. And that strategy is I see I can use one of my new trig identities. Okay. So I'm going to pick the side that has my new trig identity and hope applying it will solve the problem. So we now know that sine of alpha plus beta is equal to sine of alpha cosine beta. And then let's go make sure that we remember the sign here correctly. But you might already remember it went sine of alpha cosine beta. Next will be sine of beta cosine of alpha. Okay. But if you don't remember the sign that goes in the middle here, let's go up and look. We have sine of alpha plus beta. That's the third equation here. And you can see that the sign in the middle matches the sign in the trig function. So we'll go ahead and we'll put that addition sign here. And this is all over cosine of alpha cosine beta. All right, now this might be one that maybe you are feeling a little bit stuck on. Okay. Well, we could start working with the other side if we choose to do so. Let's do that, and then maybe we can see how these two are equal. Okay. So if we instead start with the other side, okay, as of right now, this looks nothing like sine of alpha plus beta over cosine of alpha cosine beta. But if we rewrite tangent in terms of sine and cosine, maybe it'll get us a step closer. Okay, so we have sine of alpha over cosine of alpha plus sine of beta over cosine of beta. Now, this is actually looking closer to this thing here. Let's get a common denominator and add these two together. So if we do that, the common denominator is going to be cosine alpha, cosine beta. So we'll have to multiply the sine of alpha, cosine of alpha, by a cosine of beta over cosine of beta, plus, and then we have our sine of beta over cosine of beta, and for that common denominator, we're going to need a cosine of alpha involved here. And finally, combining all this gives us sine of alpha, cosine of beta, plus sine of beta, cosine of alpha, all over, and then it looks like we have cosine of alpha, cosine of beta. So we have now shown that both the left and right hand side of this equation are equivalent because they are both equal to the same thing. Before we move on to the next example, I want us to move up here and look at example A here for a second, or part A of example 3. This right here, we actually proved an identity that we will get in our next section. Okay? And these identities are going to be the sum to product formulas, okay? Or sum to product identities. And again, we proved one of them here, and we'll get that in the next section. So moving on to part C. Once again, I think that you can figure this out on your own. So I think it'd be worth pausing the video and giving this one a try. And I am not going to change my strategy here. I'm going to start off with this side that I know I can use these new trig identities on. Okay, so there's our left-hand side. Let's use our new identities. This should be cosine of alpha, cosine of beta, then the opposite sign in here, and then sine of alpha, sine of beta. And then this is all over, and we're going to use our one of these new trig identities for the cosine of alpha minus beta as well. So we have cosine of alpha, cosine of beta, the opposite sign, sine of alpha, sine of beta. Now the question is, how on earth is this equal to this stuff over here with tangent? So I do notice one extremely helpful thing here. Notice this one and this one here, and also notice how these two terms here are also the same. Okay, point is, in that left-hand side of that fraction, there is a 1 in the numerator, 1 in the denominator. The expression that we have here has a similar thing happening. It has this cosine alpha, cosine beta in the left, in the numerator and denominator. Okay. Well, why don't we just try to make this look like this as quickly as we can? Why don't we make this highlighted portion equal to 1? Okay. Well, how could we make that highlighted portion equal to 1? What would we have to multiply by? we could multiply by 1 over cosine alpha cosine beta. And we can do this in both the numerator and denominator. Right, this is equivalent to just multiplying by 1. So we're going to make it look different, but we're not going to change what it's equal to. And we're going to distribute, right? So we're going to have to multiply this thing here and this one here by the 1 over cosine alpha cosine beta. So for that first product here, cosine alpha times cosine beta times 1 over cosine alpha cosine beta is just going to be 1. And in fact, we can take care of this bottom one down here too. We know that that'll be a 1. And then we have minus and plus. Now, note, let's not skip a step here. Let's just go ahead and multiply. We should end up with sine of alpha times sine of beta times 1 over cosine alpha cosine beta. And so that'll look like sine alpha sine beta all over cosine of alpha cosine of beta. And actually the exact same thing happens down here in the denominator. Sine of alpha sine of beta all over cosine of alpha cosine of beta. And notice sine alpha over cosine alpha, that's, well, tangent of alpha. And sine of beta over cosine of beta, that's tangent of beta. And in the denominator here, sine of alpha over cosine alpha is tangent of alpha. In fact, it's the same thing as what happened up above. We'll have tangent of alpha, tangent of beta. And we have now proved this identity.